Engineers have long dreamed of creating a wonderful material that can revolutionize construction. In 2004, their dream came true. British scientists first created graphene, one of the forms of nanocarbon that is only 0.3 nanometers thick, 1,000,000 times thinner than a human hair, but it can withstand colossal loads. Many immediately predicted a great future for it, and a little later, scientists were given the Nobel Prize. However, mass adoption did not happen. And only now, after 15 years, the first real opportunities have appeared to use the material of the future in commercial products. Supersubstance is made from ordinary graphite, which consists only of carbon. Nevertheless, due to its special crystal lattice in the form of hexagons, graphene gains many unusual properties. For instance, it can be both a conductor and a semiconductor, which makes it sought after when creating chips with higher characteristics. But the substance gained great popularity in another area: construction. Scientists have found that graphene is 200 times stronger than steel. The ultra-strong material usage immediately interested engineers and designers. After all, with light but strong graphene, you have the opportunity to build more complex structures of buildings, bridges, and even skyscrapers. After conducting several studies, scientists have found that one of the best combinations will be that of graphene and concrete. As a result, such a substance will receive increased strength by an average of 30%, good water resistance and thermal insulation, and its capabilities as a conductor can be used to build electric roads, on which Sweden is experimenting. However, if graphene is so popular, then why is it still not used on a vast scale in construction? The main problem with the mass adoption of graphene is its 2D form. In other words, graphene is created in the form of ultra-thin surfaces that break easily if you try to give them a three-dimensional shape. Therefore, it is necessary to constantly come up with new technologies to adapt it to each substance. For example, in Britain, the nationwide engineering construction company has come up with its own way of creating concrete with graphene. They use hydration, the attachment of water molecules to molecules and ions of other substances, and gelling to create a paste-like concrete to which graphene is added. After chemical reactions, pasty concrete dries out and acquires new property: increased strength, elasticity, and water resistance. The experimental concrete named concretine was first used in the spring of 2021 on part of the floor of a new gym in the British city of Amesbury. The company itself considers it to be very effective not only in terms of the quality of the material, but also in terms of economy. The service life of concrete is much longer than that of its conventional counterpart. In addition, the creation of concretine does not require any special modernization at the factories. The technology can be easily applied everywhere. As noted by Alex McDermott, co-founder and managing director of Nationwide Engineering, the company plans to rapidly expand the scope of the new building material. Together with our partners at the University of Manchester's Graphene Engineering Innovation Center and structural engineers HBPW Consulting, we are rapidly evolving our knowledge and experience and are positioned for wider industry deployment through our construction frameworks, becoming the go-to company for graphene-enhanced concrete. Another innovative technology for using graphene in construction was invented by the local government of the British town of Northumberland, together with scientists. The most pressing challenge faced in the city is the roads. Due to the large traffic flow and frequent weather changes, road sections have to be constantly repaired. Therefore, it was decided to try adding graphene to the asphalt. For this, special plastic and graphene granules were invented, G-Pave. The new technology has already been tested in the UK. As National Highways Manager Graham Watt notes, laboratory trials have been a success, and the on-site trials in Northumberland will be a world-first use of graphene in road production. The A1 highway was chosen as the test site. The builders removed the asphalt completely. They put unprocessed graphene on the road and put asphalt on top again, but with G-Pave granules. The experiment took place from September 19th to November 1st, 2021, and now scientists are studying the results. This technology is expected to help extend the life of the pavement and reduce the frequency of repairs. If successful, the new granules can be used on all roads in the country. The Changemaker 3D company has decided to implement an unusual approach. They decided to take as a basis the old idea of using concrete inside which there are iron bars. This is the technology that most modern skyscrapers were built on. Instead of such reinforcement, they rather propose to use thin graphene filaments. This will increase the quality characteristics of all concrete, allowing them to construct buildings even higher and stronger. For this idea, the Printfrastructure project was created, which with the help of a huge 3D printer will have to pull graphene filaments and at the same time fill it with concrete. The mobile unit can be easily placed in hard-to-reach places, and management via a special computer will significantly reduce the number of builders on the site. It is estimated that this technology will help reduce the amount of concrete required for construction and eliminate the need to install cranes on the construction site. Great cost savings. Another major benefit will be a 50% reduction in carbon dioxide production. After all, conventional concrete production accounts for 8% of all greenhouse gases. Trials are planned to begin in 2022. The company will be engaged in the construction of infrastructure in the country's railway sector. Similar experimental technologies for the use of the miracle substance are being developed with might and main by many companies. They reasonably believe that whoever is the first to succeed in this field will quickly become the leader in the new construction industry. More and more companies are joining this race every month, and we can already see how graphene is changing the rules of the game in the construction field before our very eyes. What do you think of this? Will graphene be able to gain its place among building materials in the coming years, or will it take more time? Please write your opinion in the comments.